In this segment, I just want to do a little practice solving systems of two equations. So the first one, we want to review solving graphically. If I want to solve the system graphically and I want to use my calculator, I need to solve both equations for y. So the first one, just add the 1 over and then subtract 1, and you've got your y equals 2x minus 1. The second one, we're going to have to subtract the x and then divide everything by 2. So you can show that by doing, negative x and divide that by 2 minus the 7 divided by 2. Or some folks like to have the entire quantity, negative 7 minus x on top, so put it in parentheses, divided by 2. Either way, it doesn't really matter. So we're going to take this and we're going to graph it. I always start with a standard window, and usually that's sufficient, so zoom 6, and I see my crossing point. Now I need to get to this calculate menu, so I look for it. It's right here above trace. Second, trace gives me calculate. Number 5 intersects, and it wants to know, is this your first curve? Yes, it's on that line. Now it's on the other line. Yes. And now guess, so I move the cursor till I'm at the crossing point and hit enter, and I get my answer here. I strongly suggest that you take that answer of -1, -3, and you plug it into your original. You may have had an arithmetic mistake in solving for y. So -2 minus a -3, -2 plus 3, yes, that's 1. -1 minus 6 would be -7, so we did good. Right, here are two other examples, but I've used an algebraic method for solving. The first one, I think it's a good method, a good example of substitution. Why is that? Because this top equation, it's got a plain little x here. It'd be really easy to solve for that. So if I want to solve for x, I would add the 2y over to the other side, and I've got my answer here. Now what do I do with that expression? I take this expression and I put that in place of the x in the other equation. So we erase the x that's there and put in the 3 plus 2y. We get this, distribute, and then try to collect our like terms, and all the variables, in fact everything, drops out and we get 0 equals 0. Well, when that happens, remember that's one of our special cases, we ask, is it true or false? It's true, so that means we have infinite solutions. We also call that a dependent system. Right, now this other one here, I could do the substitution method. I would probably solve for this y in the second equation because that's the easiest one. But just for review's sake, I'm doing this one by additional elimination. And when I'm going to do that, I'm going to look for one of my variables, doesn't matter which one, and then flip-flop the coefficients. So that's a 7, that's a 1, so I'm going to multiply the top by the 1, the bottom by a 7. I make sure that my signs end up being negative, so if I multiply on the top by a positive 1, that would be negative. So down here I need to multiply by a negative so that this ends up being a positive 7y. Distribute through and you get these two equations. We're going to add so that we get -7x equals -21. Our y's dropped out, and we got x equals 3. That gets plugged into the other equation, and we solve for the y and get our ordered pair answer of 3, 1. Now this last example is a lot more interesting because it's got all kinds of stuff going on. I've got fractions in here to start with. They might look intimidating, but we can clear them. All we have to do is find that LCD of the equation and then multiply all the terms by that. So looking here, 5 and 3, my LCD would be 15. So I'm going to take 15 times each of these and get my answer. Now I want to remind you, on your calculator, you can quickly do fractions. So 2 divided by 3 times the 15, oops, not 0, times 15. And there we got our answer of 10. So you don't even have to do that in your head. You can just use your calculator and you should get that equation up here. Then the bottom equation, our common denominator would be 6. So once again, distribute 6 all the way through, including to this whole number, and we get this new equation down here. 3x minus 2y equals -6. I'm going to do my little trick of flipping my numbers here. So I'm going to put the 2 on the top and the 9 on the bottom. And let's see, that would be a positive, that's going to be a negative, so our signs are good. We don't have to tweak them. Distribute through your 2 on the top, your 9 on the second equation, and this is the new set we have. So we're going to add our x's, add our y's, and add our constants. The x's, we get 47x, and our y's dropped out, and we get equals -564. Solving for x, we get -12. Now we have to take that and plug that back in, and I don't go back to the fractions, I go back to this one here, the 3x minus 2y equals -6. plug in my negative 12, and I should come up with y equals negative 15. So our answer is the ordered pair negative 12, negative 15.